All right, so I'm going to look at a completing the square question where there is a coefficient on the x squared, where there is a number in front of the x squared, and looking at a question where I'm asked to both solve it and sketch it. And the and sketch there is significant here because to just solve these when there's a coefficient on the x squared, the easiest approach is probably just to divide across by 5. Divide across by whatever's in front of the x squared, divide everything by that. Then you'll end up with something like I did in the other video. You'll often get fractions that you have to deal with, but if you follow the same steps and you use your calculator, it's generally fine. And you'll see if you can look up how to solve completing the square questions, that will often be the approach that's suggested, dividing across. Now, the dividing across isn't great when it comes to sketching. It requires us to kind of do a kind of awkward kind of fix to get the vertex, to get the y in the vertex. So what I'm going to do here is a slightly different approach, which will make the solving maybe a tiny bit harder, or we just have to bear something in mind when we're solving it, but will make the sketching easier. So overall, I think is the better approach to take when there's a coefficient on the x squared. Okay, it's not a million miles away from just dividing across by the 5. So what I'm going to do is I'm going to factorize the coefficient of the x squared just out of the x squared and the x term. So I'm going to factorize 5 out of those two. Okay, so again, it's always the coefficient of the x squared that you'll factorize out. You don't care if it divides evenly into this number here. Okay, so it is just a fix to kind of get us to the solution. So I'm going to factorize 5 out of these two. So 5 brackets x squared. This is just going to be minus 4 over 5x. So 5 doesn't go into 4 evenly, so it's just 4 over 5 when you factorize the 5 out. You can move the 2 over then as well, so equals minus 2 becomes plus 2. And again, I don't need to factorize it out of the 2 as well, okay? So I'm just factorizing it out of these 2, that's fine, okay? Like if you look at this, if I multiplied the 5 out, 5 times x squared is 5x squared, 5 times minus 4 over 5x is minus 4x. If I brought the 2 over, it'd be minus 2, so I would still be back here, okay? So I haven't really changed the equation here, okay? I've just kind of factorized and I've moved some stuff around, but it's still the same equation. Now, it is inside this bracket that I'm going to focus on completing the square. Okay, so I am just looking for just x squared on its own. Okay, so I am making it like one of these, like the one I've done in the other video. So it's just inside here I'm focusing. So I'm going to have the 5 outside here. And my 2 is over there. So 5 brackets. How am I going to complete the square in here? Well, the same way I always complete it. Okay, so minus 4 over 5 divided by 2 and then square it. Okay, so what is minus 4 over 5 divided by 2? Minus 4 over 5 divided by 2 is minus 4 over 10, which is minus 2 over 5. Okay, so that's what I'm going to put in to this bracket. All right, so that I can change that to something like this, okay, to a binomial squared. So I've got my x squared, I've got my minus 4 over 5x, and then I'm going to add on this squared, so plus minus 2 over 5 squared. Okay, equals 2. Now, I've added something to the left-hand side. I need to add it to the right-hand side. It is very easy to say, I've added minus 2 over 5 squared to the left-hand side. I need to add that to the right-hand side. But if you look at that left-hand side, your minus 2 over 5 squared is inside a bracket that's being multiplied by 5. So to add the same thing to the right-hand side, you need to add on 5 times minus 2 over 5 squared. Okay, if you just added minus 2 over 5 squared, you wouldn't be adding the same thing to both sides because you're putting this inside a bracket that's being multiplied by 5. So you're adding that in so that you'll be able to complete the square inside that bracket. Because you add that in, you add it to the right hand side, but bear in mind that this one is being multiplied by this, so you need to multiply the one you add on the right hand side by 5 as well. Okay, now inside that bracket I've got x minus 2 over 5 to be squared. Alright, so remember, it's always the x and this that goes into that bracket. Okay, if you were to multiply that bracket out, x by x is x squared, minus 2 over 5 squared is minus 2 over 5 squared, and then x by minus 2 over 5 by 2 is minus 4 over 5x. Okay, equals, just plug that right hand side into your calculator. Okay, so 2 plus 5 brackets minus 2 over 5 to be squared is 2 4/5. I'd probably just leave it as a fraction, so equals 14 over 5. Now, this is where I would suppose I'd split it. This is where I kind of go down this way to solve it by square rooting both sides eventually. And maybe over here I'll bring the 14 over 5 and read the max and min point on. So I'll do that. I'll solve it first. So I've got 5 brackets x minus 2 over 5 squared is equal to 14 over 5. So before you square root the left hand side, you're going to want to get rid of that 5. Okay, so that's a multiply by 5. If you bring it over, it becomes divided by 5. Or another way to think of it is to get rid of that multiplied by 5, I'm going to divide both sides by 5. Okay, so that'll get rid of that, and then 14 over 5 divided by 5 is just 14 over 25. So 14 over 5 divided by 5, 14 over 25. So get rid of that 5 now, so I have got x minus 2 over 5 squared is equal to 14 over 25. I want to get rid of that squared, so I'm going to square root the left hand side, get the square root of the other side, and don't forget your plus and your minus case. So the squared and the square root cancel each other out, so you've got x minus 2 over 5 equals plus or minus root 14 over 25, bring the minus 2 over 5 over, x is equal to 2 over 5 plus or minus root 14 over 25. So just plug that into the calculator to get your two solutions then. So 2 over 5 plus root 14 over 25 is that. So if I was asked for my answer in surd form, there it is. So do always still plug it into the calculator to get it in simple surd form. I'm looking for it in decimal form, so just change and I get 1 point, I got the two decimal places, 1.15. So x is equal to 1.15. And then if I just change that to a minus in the middle, change minus 0.35. So there's my two solutions. Okay. Now I'm going to write, I'm just going to move the 14 over 5 over so that it's in this form. Okay, everything over one side equal to 0, and that's where I'm going to read a few bits of information off. So I've got 5 on x minus 2 over 5 squared. If I bring 14 over 5 over, it becomes minus 14 over 5 equals 0. Okay, and what information can I get? I'm expecting this to be in the form a brackets x minus h to be squared plus k equals 0. So I'm expecting x minus h and I've got x minus 2 over 5. So that means x is equal to h. My axis of symmetry is going to be x is equal to 2 over 5. Or 2 over 5 you can also write as 0.4. You might have to have it as a decimal. So that's my axis of symmetry. My vertex then is going to be hk. So again, I'm expecting x minus h. So I've got x minus 2 over 5. So 2 over 5 is h. So that's 0.4. And then I'm expecting plus k. So I've got minus 14 over 5. So that means k is minus 14 over 5. And I might just get that as a decimal. 14 divided by 5 is 2.8. So that is minus 2.8. That's my vertex. So vertex meaning max or min point. Now I can read off whether it's U-shaped or upside down U-shaped either from here or from the original function. So the original function was plus 5x squared. That being a positive tells me it's U-shaped, or you can also read it off here. The fact that that's a plus 5 tells you it's going to be U-shaped. Like if this was minus 5, you would have factorized minus 5 out, and the sign of this as well is going to tell you whether it's U-shaped. Okay, so my graph is going to be U-shaped, which means this vertex is going to be a minimum point. And the other piece of information I can read off is my Y-intercept. So you just take that from the, always comes from the kind of standard form here, okay? So it's going to be 0, whatever this number is at the end on its own, whatever the constant is, the term without any x after it, so minus 2. So 0 minus 2 is the Y-intercept. Alright, so that's all the information I need to graph it. Again, if I wasn't sure about the signs of stuff here, should they be positive or should they be negative, once there is two roots, once there is two solutions, that makes your job that little bit easier. So let's say I was to just really quickly sketch this, and let's say that's minus 1, 1, 2. So this goes through minus 0.35, so it goes through here, and 1.15, so it goes through here, and we said it would be U-shaped. So it's going to look something like that. So you've got 2 over 5 in your bracket there. That's your H, and you're not sure, should this be plus 0.4, plus 2 over 5, so 0.4, or minus 0.4? Well, where is the axis of symmetry of this graph? Is it over where minus 0.4 is, which is over here? Or is it where plus 0.4 is, which is here? And it's obviously where plus 0.4 is, so that tells me that that should be plus 0.4 rather than minus 0.4, if we're still just a little bit unsure about what the sign of that should be. The 14 over 5 here, does that mean, if that's minus 14 over 5, does that mean it's a minus 2.8 or plus 2.8? Again, if we just think about this, it goes through the x-axis twice. They're the roots. It's U-shaped, so it looks like that. So its minimum point must be negative, okay? If it goes through those and it's U-shaped, its minimum point can't be plus 2.8. It can't be up here, okay? Now, if it was minus 5x squared and I had it drawn it like that, then I'd be thinking it's a maximum point and it should be up there, it should be positive, it should be 2.8. So that tells me, yeah, this point down here is minus 2.8. Okay. So that's, as I said, when you've got those two solutions, it does make this bit, I think, that little bit easier. Or that little bit easier, okay? It can happen that maybe this number here is negative and you can't get the square root of it. That just means there's no solution. So it would mean that it looks like this, that the curve doesn't go through the x-axis. Then you do need to really remember and know the h and the k, what the sign should be, and what to expect and what you actually get. It's a little bit harder, okay? But if you have the roots, as I said, I think it makes your life that little bit easier. So really quickly, I will draw this then. So my two roots are minus 0.35 and 1.15. So I might really stretch my x-axis out because they're quite close together. My y values then down to minus 2.8. My y-intercept is minus 2. So I might really stretch this out and kind of, let me see, I don't really need to worry about the positive here, do I? So let's say this is 1, it's going to be 0, minus 1, minus 2, minus 3. So going in jumps of 2, just to give me a bit of space to draw this. And then like I'm only drawing from minus 0.35 to 1.15. So I might even go like 4 boxes, gives me kind of 1 unit. So up there, 0. So I might make that minus 1, 4 boxes, 1, 4 boxes, 2. And the reason I'm doing that is if I really squashed that, if I just made minus 1 there and 1 there, your graph would be really small, and when the smaller they are, the harder they can be to draw sometimes. So by stretching this out, I'm going to make my job that little bit easier. So what do I know? I know the roots are minus 0.35, so if I'm breaking it up into 4s, that'll be minus 0.25, this would be minus 0.5, so around halfway between those is going to be your minus 0.35. 1.15 there, there's 1, there's 1.25, so again, just roughly halfway, a little bit over. It's going to go through the y-axis at 0, minus 2. It's there. And the minimum point is 0.4. So there's 0.25, there's 0.5. So roughly there, and minus 2.8. So again, there's minus 2.5, there's minus 3. So roughly there, I would say, is where my minimum point is. All right. If you want, you can put that axis of symmetry at 0.4 on. But I find once you know the minimum point and you know it's symmetrical, I don't find it that helpful, but there it is. So just connecting these up in a U shape. So something like that, and there it is sketched. Okay, so as I said, there is a couple of different ways of doing these, but I think this factorizing out of the first two is going to overall make your life easier than dividing across. As I said, the dividing across can make the solving slightly easier, but it gives you something else to remember on the sketching side, and I would recommend this approach.